have already been learning about logarithms, and we know with logarithms, the understood base for a logarithm is base what? 10. Well, when you have a natural logarithm, you write ln, that represents natural log, and its base is no longer 10, its base is e. Okay, now, e equals a number. Kind of like we all know pi equals 3.14 and then it continues forever. Well, e is the same way. If you go to your calculator and you type in e to the first power, let me show you where the e button is first of all. Okay, look right here to the left of 4. See that button that says ln for natural log? But above it, it says e to the x power. So to actually type in that e to the x power, what do you think you have to type first? So second, and then e to the x, but type in the first power, and so it equals 2.718. Yep. You just go second, and then the ln button, because we're trying to use the e above it, and then you raise it to the first power and hit enter. Okay, that's where your natural log button are, and the base e is right above it. Okay, we're on page 26. Now let's do some examples. The natural log is log base e of y equals x, or they more commonly call it ln of y equals x. Today we're going to learn how to rearrange it from exponential to log form, but when the base is e. Okay, if the base is e, that means it's a natural log. So when you rewrite it in logarithm form, you'll write ln instead of log. You'll write ln representing natural log. And then as you can see in the equation, the exponent, which is 2, will go to the opposite side of the equation. And then the y value, which started out on the opposite side, will come over beside the ln. Now, it's kind of complicated to try to remember it that way. The way I would remember it is when you're changing it from exponential to log, instead of e, you write ln, and then these two numbers just switch sides. See how the 2 went to the right side and the 7.3 came over? Now, you can type this in to make sure that you rearranged it correctly. Okay, watch the calculator. I don't want to have to type it in again because you weren't paying attention. Natural log of 7.38. Natural log button is right here to the left of 4. 7.38, and that equals 1.998, which is basically what? 2. So that means we did it correctly. Alright, so for number 2, currently it's an exponential form, because this is like y equals your base to the x power. But since your base is e, when you rewrite it as a log, you rewrite it as a natural log. And so it'll be ln of what number? Equals 3. Now type that in to make sure it makes sense. The natural log of 20.1 equals 3. Okay, so for number 3, before we can rearrange it into log form, what do you think we should do first? Right, remove this 5 by dividing by it on both sides. So e to the x equals 5, but that's still an exponential form, and our goal is to get it in logarithm form. So in logarithm form, you have to write log, but since the base was e, you write ln for natural log. ln of what? Equals x. Now, to check this particular one, you obviously can't type in ln 5 because it just equals x. But you could go back and type in the original. Watch. I'm going to type in 5e, and then in the x place, I'm going to put ln 5 because that's what I'm saying x is equal to. So, okay, look. 5e. And then in the x place, I'm saying the x equals ln 5, so ln 5. And then when I hit enter, I get 25. Well, isn't that what it says it equals? So that means this is right. Okay, number 4, what do you think you would do first? Correct. First we'll start by subtracting the 2 to the other side. And now we have e to the x equals 32. But we still haven't done what they asked us to do. We still haven't changed it to log form. Since the base is e, when we change it to log form, we will first write of equals, okay? Since you can't check it the way it is, since this is not a number, what's our other way of checking it? Correct. Just type in the original problem, put in the x place, put ln 32. Okay, so e raised to the x, which we're saying is ln of 32, and then plus 2 equals 34. So that means we did it right. Okay, what's different about number 5? There's no e. What's the base? 5. So this is not a natural log. It's just a log. So you'll write log base of equals x. And you can even check this one. Wouldn't you just type in 5 raised to the log base 5 of 25 and make sure it says 25? Okay, now before we go down to the second section and learn how to change it the other way around from log to exponential form, I want you to go to page 27 and try 1 through 10. Try 1 through 10. Alright, do you have any questions out of the first 10? Yes. Which ones? 7? Okay, number 7. It's currently in exponential form, okay, because this is y equals, and that's your base raised to the x power. Since the base is e, this is a natural log. So when we write it in log form, it'll be ln of what? Equals, correct. And honestly, yes, it makes you want to subtract the 2 over to get x by itself, but right now they didn't tell us to solve it. They just told us to write it in log form, and that's in log form. Had they said rewrite in log form and solve, you would have continued by minusing the 2 and getting x by itself. But since they didn't say solve, you can just leave it like this. And that would be x would equal ln of 4 minus 2, whatever that is when you type it in. Okay, what did you, which is not the same as ln 2. 4? Okay, what would we do first on number 4? Okay. And so that would give us e to the 6th power equals what? Isn't it 43? Okay, but now we need to rewrite that as a log, and since the base is e, it's a natural log. So it would be ln 403.43 equals 6. And then you can check it. If you type in ln of 403.43, you get 6. So that means we did it right because it makes sense. Okay, any other questions from 1 through 10? They are? Oh, it's just this one was multiplied by 4, so it's just got one more step. Okay, any other questions? Okay, well let's go back now and do it the other way. This time they gave it to us in the natural log form, but we want it in exponential form. So the ln we will write as a base of e, because we're writing it now as an exponent. It'll be raised to the 2x power, and it will equal 5. See how this, we just wrote as base e, and those two things just switch sides, making the 2x the exponent? So what would number 7 look like? Right, and since everything in that is a value, a number value, you could check that by typing e squared. Second e squared equals 7.38. Alright, number 8. Before we can rewrite it, what should we do first? Divide it by this 8. And so we have ln x equals, okay, then we have to rewrite it into an exponential. What would that look like? Okay, can we check this? You can, but you have to check it with the original. If I type in 8 ln, but where the x is, I put e to the fourth, it should equal 32. Let's see. 8 ln, but where the x is, I'm putting e to the fourth power. And I get 32. So that means we have the right answer. Okay, number 9. What's different about number 9? It just says log. It's not a natural log. So when you rewrite it in exponential form, what will it look like? Where did the 10 come from? Right. A log with no base is understood 10. So when you rewrite that, this is still your base, so it's first, but these two flip-flop sides, that becoming the exponent. And then you can check that. 10 raised to the 1.1 power is 12. Just a little over because all of these numbers have been rounded off. Okay? Alright, now flip back to page 27 and try the bottom half, 11 through 20. Do you have any questions from 11 through 20? Any at all? Number 17? Alright, number 17, it's not a natural log because this base is not e at 6, so 6 squared equals x. Yeah, almost read 36. Number 19, you should have got 10 to the third power equals x. Okay, look, you can even check these. Like if I type in log base 6 of x, which I'm saying is 6 squared, it should equal 2 if that's right. So math log base, oops, not summation. So log base 6 of x, which I'm saying is 6 squared, which I could just go ahead and write as 36, equals 2. And that's what it says it equals. For this one, for number 19, the understood base is 10, so it would be 10 cubed equals x. Well, if I type in log of 10 cubed, it should be 3. Log of 10 to the third power is 3. So all of these can be checked. Okay, now let's start trying to solve. Now that we know how to rearrange, let's solve. Go to page 28. Alright, example 1. E to the x equals 21. The reason that it's necessary for us to rearrange into the other form is to help us get x by itself. Right now, x is not by itself, but the only way to get it by itself is to rewrite this in log form. What's the base? E. So when you rewrite it in log form, won't it be ln of equals, don't we now have x by itself? So the only step you're going to have to do now is evaluate ln of 21 by typing it in. ln 21 equals 3.04. Okay, now we're going to check it to make sure we have the right answer by typing in e to the 3.04 and making sure it's 21. So second e to the 3.04, and it is very close to 21, not quite. And what is the reason for that? Why? We rounded. Had we typed in this whole thing right here, it would have been 21. But since we rounded, it's not quite. All right, number 2, example 2. What's the base? Well, the base is e, which means that when you rewrite it in a log form, it will be natural log. So the natural log of equals, okay, so even though we rearranged it, x is still not by itself. What do we have to do? Okay, this is where you got to be careful when typing it in. It's ln of 4, whatever that is, minus 2. So when you type it in, you'll have to do ln of 4, close the parenthesis, and then minus 2 on the outside. And you get, so negative 0.6. Okay, and just like always, we can check that. If I type in e raised to the negative 0.6 plus 2, it should be 4. e raised to the negative 0.6. And then what was it? Plus 2. And I get 4. So that means I have the right value for x. Okay, example 3. What do you think I should do first? Correct. First we'll divide by 8. And so now we have e to the 2x equals what? Okay, but remember, we're trying to solve. And anytime you're trying to solve, your goal is to get the variable by itself. How can we get x by itself? Right. When we rearrange it into log form, won't that put the 2.5 on this side and the 2x on that side, getting x closer to being along? Now we divide by 2. So ln of 2.5 over 2 would be ln 2.5. Make sure you close off the parenthesis and then divide by 2, 0.46. And then you would check it by typing in 8e raised to the 2 times 0.46 and making sure it's 20. So 8e raised to the 0.46 times 2, and that gives you 20. So we know we did it right. Okay, I want you to take a couple of minutes and try 1 through 5. The first thing you should have done is rewrote it as a logarithm, and since it's base e, it's natural log of 225 equals 2x. Then you would have just divided both sides by 2 to get x by itself. And if you type this in correctly, you'll get 2.71. Number 2. The first thing you should do is divide by negative 3 on both sides and get e to the x equals 8. Then you rewrite it as a logarithm, and since it's base e, Grant, it's natural log. And then you just evaluate that. ln of 8 equals 2.1. For number 3, the first thing you would do is divide by 4 on both sides and get e to the x equals 15. And now I'm going to rewrite that into log form, but since it's base e, it's a natural log, so natural log of 15 equals x. And then to find out what x equals, you just type that in, 2.7. Okay, number 4. The first thing you do is rewrite it as a natural log. So ln of 4 equals 5x plus 1. Okay, then we know the next thing we're going to do is subtract 1, correct? So watch how I do this on the calculator. First, I'll type in the left side, ln 4, okay? And I hit enter. I have 1.38. I'm now going to subtract 1 from that value. And then what am I going to do to that value? Divide it by this 5. And you get 0.077, so 0.08. Okay, and then number 5, what should I do first? Divide by 5. So e to the x power equals 1. Now I'm ready to rewrite it as a natural log. What will that look like? And then what is ln 1? And that makes sense because anything raised to the 0 power equals 1. Anything. Okay?